All right, so if you labeled these correctly, I'm going to go over them together using our rules. Okay, so if this is a 1, oh, sorry, I did forget to tell you. I wanted you to do this. Okay, so we're going to call this X and we're going to call this Y. Okay, so even if you already found it, it's okay. If you flip-flop these and you call them Y and X, I do want you to write it like this. And then once you found those, I want you to write your answer as a point. X comma Y. And then we're going to do the same thing for 12. And in this one, I want this to be X and this to be Y. And then for 13, this is 1, hypotenuse is 1. I want this to be X and this to be Y. So notice in all three of these, the one I labeled X was the horizontal. Can you guys think about why that is? If we're writing them as points? Yeah, the x-axis, right? On the coordinate grid, the x is the horizontal, yeah, and then the y is the vertical. Okay, so using your 45, 45, 90 rule, if this is your hypotenuse, and the reason why we only have one equation is this is a leg and this is a leg. So these two legs are going to be the same. So if I do the hypotenuse equals the leg, which is x, times root 2. If I want to solve this for x, Royal, you said you already did this one, right? Okay, so what did you do to solve for x, or what would you do? Yep, so you're going to divide by root 2. And when you do that, okay, we don't want to leave it as over root 2, so we're going to rationalize. So we're going to multiply the top and the bottom by root 2 over root 2. All right, and then Jack, D, did you simplify that already? What'd you get for your final answer? So the hypotenuse is 1, so the legs won't be. All right, so let's do this part together. So we'll just multiply across. So root 2 times 1, what's that going to be? Root 2, and then root 2 times root 2, 2. Okay, and then remember, the legs are the same. So if x is root 2 over 2, y is also root 2 over 2. Okay, so the point that we're going to write for this one is root 2 over 2, root 2 over 2. Okay, if you did not do this the way I did, you should be writing the corrections on your paper. If you're doing something right now, that is okay. All right, so then for number 12, you have the short leg and the long leg. Visually, you can see that, but do you guys know how to tell based on the angles which one's the short leg, which one's the long leg? Opposite of. Yep, so the short leg's always across from the 30 degrees because it's the smallest. Long leg, the 60 degrees. Hypotenuse, which is the long one, is the 90 degrees. Okay, so that would have been something that you studied in geometry. So a lot of you caught on that if the hypotenuse is double the short leg, if this is 1, what would half of that be? Just 1/2. Okay, so if you wrote it as 0.5, we are going to write it as a fraction, 1/2. Okay, and then I want some of you to look at your next value because we do have to write it in a simplified way. And I saw that many of us weren't sure how to simplify that. So we know the long leg equals the short leg times root 3. So x equals, my short leg is 1/2. And then I saw several people left it like this. But you can multiply these together. We got to simplify. So we can put this under 1, multiply straight across. So it becomes root 3 over 2. All right, and then let's go ahead and write it in our point. So our x value is root 3 over 2. Our y value is 1/2. Now, what do we know about the triangles in 12 and 13? They they have all the same angles, right? So the side lengths are going to be the same. It's just this is rotated and it's reflected. Okay, so what is my x value going to be for this one? 1/2. What's my y value? √3/2. Okay, so this is where the 30-degree angle is now, and across from the 30-degree angle is 1/2. So across from this 30-degree angle is 1/2. Across from the 60, √3/2. Okay, so our point is 1/2 √3/2. Okay, we are gonna come back to this in a few moments. Okay, but before we start talking about how this relates to the unit circle, the first thing we're going to do is we are going to measure some angles. So I like to color code mine. It just makes it easier to find things. So we're going to be doing 3 different things on our unit circle. We're going to have degrees, we're going to have radians, and we're going to have points. Okay, so we're going to do the degrees first. Okay, so on the back you should have a blank sheet. We'll talk about that in a little bit. Yeah, today. Okay, so on your unit circle, okay, the first thing we're going to do is we are going to construct the angles of the unit circle. Okay, and I am going to go more into how this is used. It's just, we're going to do one thing at a time. Okay, but the reason why this is so important is because for the rest of chapter 11, the things that we learn about the unit circle, we're going to be applying for the rest of the year. And then when you go on to your class next year, a lot of you are taking pre-calculus. You'll be using that for most of the year. If you do trig, you'll be using a lot of it in trig. Okay, and then it'll come back around in calculus and pre-calculus.
At this time, please release all JV baseball players.
Okay, so what I want you to do is on your device, aka protractor, I want you guys to measure a 30-degree angle. If you're Alright, so if you're not sure how to make the 30-degree angle on here, if you look at this dial, you can find the 30 degrees, okay, and you're going to line those up. Okay, so you're going to find the 30 degrees, okay, you're going to line those up, and then what you need to do is you need to put that at the center. I'm going to do this in pencil. Please feel free to do the same. Okay, so you want the center to match the center here. Okay, and then, bless you. And then after you've done 30, you're going to do 45 degrees. So the next one is 45. And then if you are using a regular protractor, when you're making those lines, what you do is you line it up with the center here. And then you're just going to put a little dash where the 30 is. And once you put that little dash, you connect it to your circle. Okay, and then do the same thing for the 45. Okay, so your 45, you're just going to make a dash where that is, and then you draw the line that goes through that. Do any of you know what the last angle is? Yeah, 60. So it goes 30, 45, 60. Do those numbers sound familiar? Yeah, they're the what? Yeah, they're the angles in the special right triangles. The 45, 45, 90, the 30, 60, 90. Okay, and then I want you to label them. So we're going to label this as 30 degrees. If you can label them here like me, that would be great. Okay, and then this one is 45 degrees. And this one is 60 degrees. Okay, we are also going to label the first degree, which is right here. It is at 0 degrees. And at the top, we have 90 degrees. What would I label this? 180, great. We remember this one here? Yeah, nice. Okay, and then we are going to label the full way around, which is the 360. Okay, that's the only place that's going to have the two spaces, the start and the end. Okay, now once you have those, you're going to take your straight edge, and what we're going to do is we are going to extend these lines from quadrant 1 into quadrant 3. So we're going to take these lines from 30 degrees, and we're going to do the first extension here. It's okay if there's a little bump. If you want to erase and do it again, if it didn't turn out the way you want, that is fine. Now, what type of angle did I just make here? A straight angle. And a straight angle is how many degrees? 180. So if I measured this angle to be 30, and this angle is 180, you guys know how we can find this guy? Add it. Yep. So what's 30 plus 180? Okay, so then we're going to label that line. 210. Okay, and then we're going to extend the other lines as well. So we're going to extend the 45 into quadrant 3. And we're also going to extend the 60 degree into quadrant 3. Okay, and then what I suggest is using the pattern that you see here. So from 30 to 45 is how many degrees? From 30 to 45. 15, yeah, from 45 to 60, 15. So when you extended these, it's going to be the same pattern. So if you just add 15, what do you get? Yeah, 225. Okay, and then I'm going to give you time to find that one. Okay, and then the next thing we're going to do is we are going to draw those angles in quadrant 2. So again, we're going to make the 30-degree angle. We're going to do a reflection. Okay, so when you do the reflection, again, I'm just going to put this at the center. We're going to draw the 30-degree angle from the other side of the x-axis. Okay, so this is from the left side of the x-axis. So we're going to draw our 30-degree angle. We're going to draw our 45-degree angle. So at 45 degrees, we're going to center that back here. And then we're going to do the 60 degrees. Okay, and then you can follow that pattern again. So notice that it goes from 0 to 30. So it goes 30, 15, 15, 30. So the same thing is going to happen on the other side. It'll go 30, 15, 15, 30. Okay, so if I add 30, I get 120 plus 15, 135. Okay, and then we guys add that other one in, and then you guys know our next step? Yes, go to quadrant 4. Okay, if you're already done with this, feel free to close your eyes and imagine what you're going to do when you get home on this beautiful day. Enjoy just taking it slow for a moment. Okay, and then again, finish the pattern. So I want you to have all of those angles in degrees written on your unit circle. Okay, so some of you are going to be a little faster at this, some of you are a little slower, that's okay. Okay, as you're filling in your degrees, you can start to think about your radians and what are some of the radians that you know. If you want to put a few of those on your circle, you can. Okay, so when you've learned this, we are going to have a unit circle quiz where you're going to fill it in. So we're really going to concentrate on these patterns so that it's not memorization, it's a recognition of the patterns. So a few things that we know in radians is if it's 0 degrees, it's going to be how many radians? That would be at 360. So at 360, it's 2 pi. Where does it start? Well, 0, right? What's 0 times pi over 180? 0. Okay, we also know at 180, it's what? Pi. Now the rest of the radians relate to the top of the unit circle because the top of the unit circle is 1. When we're dealing with fractions, okay, we think of 1 as the whole. So if this is 1 pi, where is half a pi? 90. How do we write that? Because we're not going to write it as 1/2 pi. Pi over 2. Great. Okay, so we're going to put that here. Okay, and if this is half a pi, where is a quarter going to be? 45. Okay, so this is going to be pi over 4. Okay, so when you're thinking of this as the fractions, right, this is 1/4. If I split it up, right, you guys agree this is 1/4. Sometimes it helps to see it like this. So if this is 1/4, this is 2/4 or a half. What's that going to be? 3/4. Yep, 2 pi over 4. Yep. Okay, so this is 1 pi over 4, 2 pi over 4, reduce, 3 pi over 4, And at pi, I would be at 4 pi over 4. Can you guys put where 5 pi over 4 is going to be? Okay, so at 0, if you notice that pi over 4 is 45 degrees, 2 pi over 4 is at 90, add 45 to get to the next one, 3 pi over 4, 4 pi over 4 is here, okay, and then 5 pi over 4 is going to be at what? 225. Yep, so go another 45 degrees, so that will be the 5 pi over 4. Okay, this is 6 pi over 4, but don't write that down, because what is 6 pi over 4 reduced to? Yeah, so 2 goes into both, right? So if you divide by 2 and divide by 2, we're going to write the reduced form, which is 3 pi over 2. Okay, so just to get us back on track, remember that here we were at 4 pi over 4. I went 45 degrees to 5 pi over 4, another 45 degrees to 6 pi over 4. So I'm going to go another 45 degrees to 7 pi over 4. And then 8 pi over 4 brings us back to 2 pi. Okay, so that should always happen. All right. Now we're going to fill in some more of the radians. Okay, so 60 degrees. 60 degrees is what compared to 180 degrees? If you were to reduce it. Yeah, it's what? 1/3. Okay, so that means this is pi over 3. And then how many degrees would I go to find 2 pi over 3? 60 degrees. So if I go another 60 degrees, I'm here at 2 pi over 3. If I go another 60 degrees, I would be at 3 pi over 3, which is pi, exactly. So I want you to see if you can write where your 4 pi over 3 and your 5 pi over 3 are. So give that a try. Again, I know for some of you that it's just simple. For others of us, it's going to take a second, and that's fine too. Okay, and then if you wanna write in, you know what the next one is, you can. So we wrote in 1 pi over 3, 2 pi over 3, 3 pi over 3, and then 4 pi over 3 is going to be here. Okay, which you guys found was 240. Now 5 pi over 3, if I go 60 degrees, is going to be here. And I always like to just go another 60 to remind myself that that's the 2 pi. Okay? All right, what's my last radian in quadrant 1? Pi over 6. Because if you think about this, 30 degrees over 180 reduces to 1/6. Okay, so that's where I'm getting the pi over 6. Now, really, we could have done pi over 6 and ran into each one of the pi over 3s and reduced them, but I try not to do that. I don't like it as much. So I'm just going to keep going 30 degrees, okay? So pi over 6, this is 1 pi over 6. This is 2 pi over 6. We reduced. Where's 3 pi over 6? At what degree? At what? 90, because I go another 30 degrees. So that's 3 pi over 6. Where's 4 pi over 6? 120. So where's 5 pi over 6? Okay, and remember, this is 1. So 5 pi over 6.
Pardon the interruption. At this time, please release girls JV and varsity soccer team.
All right, and then see if you can fill in the other ones with the pi over 6. Okay, so you're just counting. All right, so then if this is 6 pi over 6, remember, we keep going 30. So this would be 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6. What should be here? 11 pi over 6. Okay, now, when you're doing this, if you're unsure if you did it correctly, one thing that you should notice is if you follow a straight line, this is pi over 6, this is 7 pi over 6. What's a way to go from pi over 6 to 7 pi over 6? You just add pi, right? Okay, so those across from each other should be pi apart. And then you can see they both have the same denominator. Does that happen for all of them? Okay, so this is pi over 4. If I follow it across, is 4 in the denominator? Yep. Okay, what about pi over 3? Yep. Pi over 2? Yep. Yep. So does it happen? Yeah. Okay. All right. How are we feeling about radians and degrees so far? Feeling okay? All right, I will take it. All right, so when you fill this in, it is going to be something that's timed. So I always say just you can remember the first quadrant. Everything from there is a pattern. Everything from there you can count. Now the last thing we're going to do today are the points on the unit circle. So one thing I need to reveal to you is this special unit circle has a radius of 1. Okay, so I just want you to write that the radius is equal to 1. Okay, and we think of these as the y and x axis. So if I had a circle on the axis and I knew that the radius was 1, okay, what would this point be? 1, 0. Did you say it's a trick? This is the radius of 1. Okay, so this is the distance. Okay, so yes, this is going to be 1, 0. Because you go over 1 unit, up 0. Okay, what would this point be? 0, 1. What would this point be? Negative 1, 0. Yep, so now I'm on the left side, so my x is negative. Okay, and then here, my point is 0, negative 1. Okay, so each one of these places that we have written down has a special point on the unit circle. I'm going to show you where these points come from, and then we're going to write them in together for quadrant 1. Okay, so you don't have to draw this. I just want you to pay attention with me. So we measured this angle here to be 30 degrees. Okay, if I make this into a triangle, it becomes a 30, 60, 90 triangle, right? Okay, so if I think this is x because it's with my x-axis, and this is y because it's parallel to my y-axis, this looks like which one of our triangles on the front side, 11, 12, or 13. Okay, it looks like number 12. So for number 12, what was our point? So you guys wrote out the points, right? Root 3 over 2 and 1/2. That's the point. How do we know? Because the hypotenuse is the same thing as the what? The radius. The radius of the unit circle is what? 1. So if I were to solve, I would have done what we just did earlier today. Okay, so when you solve, you would get the root 3 over 2 1/2. Okay, which means our point at the 45 degrees is going to be what? Not everybody at once now. Yeah, let's look on our sheet, okay? So if I have a 45 degree and the radius is 1, the x is root 2 over 2, the y is root 2 over 2, okay? So again, you could solve that. That's exactly what we did earlier. Okay, and then with the 60 degrees, okay, again, all we're doing here is saying, hey, this is 60 degrees. If that's 60 degrees, and I know the radius is 1, I can find my x and I can find my y using my special triangle rules. And that's what we did together today. So for pi over 3, it is 1/2 and root 3 over 2. Okay, so a lot of people end up memorizing this one, and then these two look really similar. So sometimes that's a little bit confusing. Okay, I'll tell you a pattern if you guys tell me something about all of them. What do you notice about all the points?
They're all over 2.
Yeah, they're all over 2. Okay, so when you have to do this, the first thing I would do is just make the denominator 2. Okay, do you guys want to know a pattern to remember the rest? Yes, please. Okay, I will tell you. All right, so see this is 0 here? Okay, and then look at these. 1. And they're actually all square roots, right? Because square root of 3 doesn't simplify. Square root of 2 doesn't simplify. What's the square root of 1?
1.
Square root of 0? 0. So they really do go in order. So even that's how I'll remember it. If I second guess myself which is which, I'll say, okay, this is where the 0 is. So then the 1 comes next, then the 2, then the 3, and then this one is 0, and then 1, 2, and then 3. Okay? Now, if you can remember quadrant 1, you can find every other point on the unit circle using things that you learned a long time ago, which is the signs of the quadrants. Because in quadrant 1, what do we know about all the x coordinates? They're positive. So you have a positive x coordinate and you have a positive y coordinate. Okay, in quadrant 2, what do we know about the x coordinates? Negative, and the y's are positive. Okay, so, well, I'll come back to that. Let's finish our quadrant journey. Okay, so in quadrant 3, the x's are negative, great, and the y's are negative. And then in quadrant 4, the x's are positive and the y's are negative. Okay, and that's just based on the position, right? So a positive x, a negative y. Negative x, negative y. negative x, positive y. Okay, now everything from here is a reflection. So if I reflect this across the y-axis, what degree do I end up at? It's a reflection. 120. Because remember, it has to be the same distance away. So if it's 60 degrees in the right direction, I go 60 degrees in the left. So I take this same point that I had here and I make it a negative x, so negative 1/2, and a positive y. Okay, and you can fill in the whole unit circle now. You can fill in all the points, so you can go ahead and do that. I'll do a couple more with you if you need just some more reassurance. So here, if I am reflecting this point, okay, this is 45 degrees. So if I go 45 degrees in the other direction, now I have negative root 2 over 2 and positive root 2 over 2 because it's going to fit this. So a negative x, a positive y. Okay, and then here I will reflect the 30 degrees, so it's 30 degrees from here, so it's 30 degrees from here. So I'm going to do negative root 3 over 2, 1/2. So anytime you have something that's over 6, do you see how 1/2 is second? Here 1/2 is second. It ends in the over 4. You have the root 2 over 2's. Okay, and then here the 1/2 would be first if it was power of 3. Okay, and then I want you guys to fill, I'm going to have you guys fill in the rest of these. Okay, so I'm going to give you a couple moments to do that now. You're done. You can do a 2-minute meditation. Maybe think of something positive that happened to you today. Maybe there's a moment you can think of that brings you joy. It can be a person, it could be a place, it can be a memory. You're wondering why my hands are like this? Have you guys seen The Lion King? Of course. Do you know who I am? Kaden, you know? You Lion King fan? Whenever I think of my meditations, I think of Rafiki. Rafiki from The Lion King. Remember he looks after Simba? It's a baboon. Yeah. I think that's just his face, right? Yeah. It is. Okay, and then once you have filled those points in, we're going to start talking about how these relate to trig functions. So remember in 11.1 and 11.2, we talked a lot about sine, cosine, and tangent. Okay, so what the unit circle does is it relates these points to the sine, cosine, and tangent. Okay, so we're going to write down what that relationship is below. Okay, so every point that is on the unit circle has the form cosine of theta, sine of theta. Okay, so every point that we wrote down, okay, we were thinking of them as x and y. Okay, your x is related to cosine, and your y is related to the sine. Okay, so just like a coordinate point here, your x is the cosine position that goes first, and then your y is the sine position, and that will go second. Okay, the tangent is special. Do any of you know how to find the tangent with trig functions? Yeah, do you know what it is? Do you remember what it is? It's just sine. What? Yeah, it's opposite over adjacent, so it's so it's sine over cosine. Yeah. Okay, so the tangent is going to be equal to the sine over the cosine, or if we think of that in terms of y and x, we can find that as y divided by x. Okay, and then we are going to be finding values of sine, cosine, and tangent with the unit circle. Today we're just going to look at two quick things. Okay, so I promise you we're not going to do too much. But remember that all of your homework in chapter 11 is mandatory, and so the next few sections is going to be a worksheet. Okay, so you won't have any homework tonight besides finishing the special triangle worksheet if that's not done, or filling in anything in your unit circle if that's not done. Okay, and then we're going to use our unit circle to just help us with the first two. All right, so the first part of this sheet is exactly what we wrote down. The key concept is that the points on the unit circle are given as the cosine and then the sine. And then we know that each quadrant has a positive or negative value assigned to them. So each point, the x and the y, relates to your cosine and your sine. Okay, and then each quadrant is going to have a positive or a negative value assigned to each function. What we usually do is we remember which quadrant has a positive value, and we use this acronym, all students take classes, or some books will say all students take calculus. So usually you'll see me write out A, S, T, C, all students take classes, and that correlates to where these are positive. Okay, so in quadrant 1, the sine is positive, the cosine is positive, the tangent is positive. Okay, so the A stands for all of the trig functions are positive. Okay, what do you guys think the S stands for in quadrant 2? The sine. In quadrant 3, it is the tangent. So all sine, tangent, cosine. Okay, that's how you can remember where they're positive. All students take classes. Okay, and if it's not positive, then it's negative. All right, so we're going to use our unit circle to find the exact value, which means we aren't going to be using our calculator. We're not going to use any decimals. Okay, we are going to be using our unit circle for this. Okay, so we're going to use the UC. That is the unit circle. Okay, and we're just going to do A and B today. Okay? Okay, so for part A, we want to find the cosine of 225 degrees. Okay, we want to find the cosine of 225 degrees. Okay, so remember, cosine relates to which coordinate? The x. Okay, so what this means is find the x value at 225 degrees. Okay, once you found it, I want you to write it down here. And then you can see if you can do B. If you need me to help you, I will help in just a moment.
Teachers, please pardon the interruption. At this time, please release all varsity girls tennis players.
All right, so then what do we get for the cosine of 225? Negative root 2 over 2. Is that what you guys got? So if you go to your unit circle, okay, at 225, just look and see what your point is. This is a reflection, and they're both negative. So you had negative 2 root 2, negative 2 root 2. So my x coordinate, in this case, they're both the same, but okay. And then for the sine, instead of finding the x value, I have to find the what? Yep, so you're going to find the y value at 315 degrees. Okay, so go ahead and use your unit circle to do that. And then just clasp it in. All right, what do we get? Negative root 2 over 2. Yes, so at 315, that was a negative x. It was negative root 2 over 2. Okay, so you can have the same value for different functions and different degrees. Right, and then we'll finish the rest of these notes tomorrow.